Hi guys. This video is to help you guys in understanding what is going on with the Meteor Madness Lab. I'm sorry, the Massive Meteor Lab. I forgot the name of the title of it. As usual, you want to come into class, you want to open up Canvas to our homepage and click on Massive Meteors. That is what we're doing today. Hopefully things went well and we had a nice little discussion about your do now that you put into your notebooks about what exactly is a meteor. And we talked about meteors as just very small chunks of rock falling towards the Earth, leaving a streak in the sky. Was the basic gist of that. And so we're talking about force right now. We're talking about force equals mass times gravity. And how do you measure that? Well, if we're talking about meteors, you can probably measure that force from the impact that it has on the Earth. So what you guys are going to be doing is that you guys are going to be doing a lab that you'll be dropping an object into sand, like a meteor would be impacting the Earth. So what you need to do is you need to click on today's work, Massive Meteors Lab, and it's going to open up a Google Doc for you. Make sure you put your name, period, and date. And let me explain to you guys exactly what's going to be happening at this lab. At your lab stations, there is a box of sand, like this. There are two marbles, one that is a steel marble, one that is a glass marble. You'll also have a meter stick. You'll also have this funky little ruler right here for measuring something that's rather small. It's actually meant to make circles, but we're going to use it for actually measuring stuff in centimeters. Okay? I'm going to move my camera over into the screen before we get going here. So here is the bucket of sand that everybody will have at their lab stations. This is what it looks like. All right? And essentially what's going to be happening is that we're going to be dropping the glass marble and the steel marble into the sand. What are we going to be measuring? Well, the pre-lab question is how many centimeters will a glass marble have to fall in order to have the same impact as the same of a steel marble that is the same size. Okay, so if I were to take every time you do an impact, you have to use like your Etch-a-Sketch skills, reset your sand there. If I hold these two marbles at the same height and I drop them, what do you think is going to leave a bigger crater? The steel marble or the glass marble? Take into account that the steel marble has more mass. And remember, our formula that we're learning about right now is force. Force equals mass times acceleration. So if you increase the mass, then you are going to get a bigger force, a bigger impact. So you'll probably come to the conclusion, if I drop these from the same height, the steel marble, you can see, has left definitely a larger crater than the glass marble. All right? So the wild guess question is, what happens if I change the height of the glass marble? Instead of dropping it from this height, what happens if I drop it from this height? Will that increase the size of the crater? Well, our formula says yes. Force equals mass times acceleration. Okay? The glass marble has a smaller mass than the steel marble does. It's a smaller mass. However, if I increase the height in which it's falling, that will increase its acceleration. It's had longer to accelerate, and it will hit the ground with a greater impact. So your wild guess question is, if I drop this from 50 centimeters, so if I take my meter stick, and there's my meter stick for 50 centimeters, if I drop this from 50 centimeters and I leave a crater, That's the size of the crater. How high, how many centimeters would I have to hold the glass to match the same size crater as the steel marble in centimeters? So that's going to be the experiment. The experiment actually has nothing to do with the steel marble, other than that's going to be a prediction later on. The experiment is really how high am I going to have to put the glass marble up. Our experiment's going to be changing the height of the glass marble and looking at the size of the crater. That said, think about what I just said there. What am I manipulating? Our research question says, how does the manipulated variable affect the responding variable? I want you to tell me what the manipulated variable is. What is the manipulated variable? What is the thing that we are changing in this experiment? And how does that affect the responding variable? What are we getting, what are we measuring as a result of that change? That follows once we get that written, then we write our hypothesis. If we do this, then I think this will happen, and then the reason, and you might want to know what the reason, help you out with the reason. The reason for it probably has something to do with that equation, force equals mass times acceleration. So if we change something in the mass or the acceleration, it's probably going to affect the force. That would be a good reason. So if we do this, then this will happen because, and then that's your answer. Every lab station is going to have these things. It says one glass marble, one steel marble. For my demo here, I am using a regular old glass marble, but my steel marble, unfortunately, is a little bit larger. You guys should have about the same size glass and steel marbles. You should have a pipe pan. Actually, I decided to use these plastic buckets. It creates a lot less mess, a lot less sand all over the place in the pipe pans. One of these rulers and a meter stick. That should be at every lab station. From there, the pre-lab, what you're going to be doing is you are going to figure out the mass of the marbles, the glass marble, and the steel marble. So how do we figure out the mass? Well, first of all, we got to be really careful because something hopefully we talked about before in this class is that mass and weight are not the same thing. Your mass is how much of those elements on the periodic table, how much of that stuff is inside you. Okay? Your mass is measured in grams, and if I said I was 98 kilograms, that means on the Earth I'm 98 kilograms. That means on the Moon I'm 98 kilograms. On Jupiter I'm 98 kilograms. It doesn't matter where you go in the universe, your mass always stays the same. A lot of people always get mass confused with weight. Basically because the more mass you have, the more you're going to weigh. But really weight changes. If I weigh myself here on the Earth, I weigh 250 pounds. That means on the Moon, I'm going to weigh like 1/6 of that, which I think came out to be like 38 pounds. What's changed? Well, the Moon has less gravity, which means things accelerate towards the Moon slower than it does here on the Earth. So you end up weighing less, even though you have the same mass. So we've got to be careful to not say that we're weighing things. We're finding the mass of these things. So how do we figure out the mass of these marbles? Well, in the front of my classroom, I have some electronic scale balances. These things right here. And what's going to happen is going to lift up the lid like this. Now, this number right here, right now, it's not reading 000. If it's not reading 000, you actually want to hit this little 0 button to reset it back to 0. From there, you're going to take your marble and carefully put it onto this little tray. And when it stops rolling around, you're going to look at that mass. Right now, it's reading 28.29. I don't know if you can see that on the camera or not, but it's reading 28.29. Which means that is the mass. Once again, I use that word weight. It's really hard to go from weight to mass. But the mass of this steel marble is 28.29. You can round it off to the nearest tenth and just say 28.3 grams. Okay? Don't use my numbers. You're going to have to use your own numbers. Here's my glass marble. My glass marble is reading 6.27. So that is the mass of your marbles, the steel marble and the glass marble. The next thing you have to figure out is the size of those. And to figure out the size, we're figuring out the diameter. How big are they in diameter? So let's measure my steel marble right here. I am going to use this little tool. It's a little ruler. Don't use the inch side. Make sure you use the centimeter side. And I'm going to look straight down on this, and I'm going to measure from this point right here where it starts to the other side of the, and once again, I'm not wearing my glasses, so I'm not 100% sure, but it looks like I'm reading at about 2.0. So the diameter of this steel ball is about 2.0 centimeters, and that's what I would record for the size of the steel marble. I did the same thing for the glass marble, so we know that they're pretty close into the same size. All right. Then it says use a meter stick to measure 50 centimeters above the sand in the pie pan. Drop the steel marble into the sand from 50 centimeters, the diameter of the crater, to the nearest 1/10. In other words, the nearest millimeter. So I'm going to shake my sand here, get it all ready to go. And this is going to be the only time you are going to drop the steel marble into the sand. Most of this lab is going to be dropping. Now this is 50 centimeters, this is about half a meter. Notice I'm not going to put the ball next to the meter stick. I'm actually going to hold it away so it doesn't touch the meter stick on the way down. All right, so I'm going to put the meter stick just barely touching the sand. I'm going to go to 50 centimeters and go up, and I'm going to drop it. And it's created a crater, which you can actually see pretty good on this camera. I can zoom in on it. There we go. So you can see the crater pretty good. You can see that it's going from about right here to about right here. I like to draw little lines on there. It just makes it easier to kind of see what's going on. I'm going to use this little tool, once again, using the centimeter side. Measure where this little part spikes out from one side of the crater and put the little arrow where the other side of the crater is. And if I hold this up and I look, it looks to me like that crater is about 4.9 is what it was reading. So that'd be about 4.9 centimeters. So you're going to record that right there, 4.9 centimeters. That's going to come in important for later. Scrolling down a little bit more on this, your manipulated variable, you can responding variable. We already talked about that at the beginning, so you can just use the same manipulated respond variable you did from the beginning of the lab. The controls, before you do this lab, what are all the things that have to stay the same? Did you use the same sand? Did you use the same bucket? Did you use the same marble? Did you use the same meter? Did the same person drop all these things? Excuse me. Sand dust. All these things are the things that happen that are the same for each one. So I want you to tell me at least 3 things that stay the same for each part of the experiment, for each drop. Though I give you 5 because 3 is the absolute minimum. You really should be able to give me more than 3. Then we have the data table. Here we have the data table. We're only using the glass marble now. We're not using the steel marble. We're only using the glass marble. We're going to drop it from 10 centimeters, 20 centimeters, 30 centimeters, and we're going to measure the size of that crater. Once we get this data table figured out, we're going to go off and use Desmos. It's going to open this up. Slowly. This one's already open. Close that one out. And then you can see I've got 10 centimeters for the x-axis and the y-axis. It's open. And then right here, if it doesn't say AX plus 1.5 right here, add the plus 1.5. It puts the line into the right place. Otherwise, it just doesn't actually work. And then the A value equals 0. Once again, to get that, I can't do that with this. In order to get that red line to slope, you're going to move this little A thing back and forth. Okay. From there, we're going to go back to our lab. We're going to paste use our snipping tool and paste it right here. This is going to be a little different. This lab is a little different from the other ones. I've had a lot of people say that they didn't like the other labs a lot. Man, my camera's gone away. I had a lot of people say they didn't like they were confused on the conclusion part. So I'm breaking it down a little simpler. To do the questions, if you look at these questions, notice that these first 4 questions are all in pink. The second 2 questions are written in yellow or orange. The next 3 questions are written in green, and the next 3 questions are written in blue. There's actually a new color here, which is gray. That's gray, believe it or not. Why are they pink, orange, green, blue, gray? Well, if you remember from our previous labs, the conclusion always did the claim, evidence, reasoning, prediction, in those colors. So basically, like all the pink ones, that was your claim. All the orange ones was your evidence. Your reasoning was written in green, and your blue was your prediction. And then finally, gray is going beyond. What else can we measure with this lab? This is a little bit complicated of a question. I'm going to go over this in class. Why did I do it that way? Well, when it's time to actually write the conclusion, this is how you write the conclusion. I've done it almost all for you. So this should be an easy lab to do. After investigating behavior, see it's written in paragraph form, after investigating this behavior of the insert question here, and you'll notice that it says right after the word here, there's a little 1. Literally the answer to question number 1. That's what you're putting in that blank. I conclude that there is a blank relationship. It says insert your question answer here. Right there after the word here, you see the superscript 2. That's the answer to question number 2. Question number 3, question number 4. You can see what I'm doing here. Basically, if you answer the questions, all you got to do is plug and chug the answers, those answers into your conclusion. So super easy. Everybody should be able to do this, no problem. And hopefully we'll be able to work on these labs a little bit easier like that in the near future. All right, that's it. Good luck, guys.